So here's a question on Venn diagrams. And we're given the set of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. And we've got a set that says whether they're square numbers, a set of even numbers, and then presumably numbers that are neither squares or even. So we've got to work out, first of all, what our numbers actually are. Okay, so I've set up a table here with all our numbers, and I've got a row for squared numbers and I've got a row for even numbers. Well, 1 times 1 is 1. So yes, 1 is a square number. 4 is 2 times 2, so this is a square number. 5, 6, 7, 8, 9. 9 is a square number. 3 times 3, so 9 goes on our row there. 10, 11, 12, no. Okay, well, the even numbers are a little bit easier. So you can see now the numbers which are only even, which are 2, 6, 10, and 12, must go in the area defined as only even. Now the numbers which are only squares and not even, well, we've got 1 and 9. Now what about numbers that are both square and even? Well, there's only one candidate for that, and that is 4. It's in the square circle, and it's also in the even circle. So the numbers that don't apply to either square or even are 3, 5, 7, and 11. So these numbers all now are popped in the diagram on the outside, and that's completed the Venn diagram. So that was part A, and now we're going to look at part B. And part B is this. One of the numbers is chosen at random. Write down the probability of it being S and E. Well, there is only one number that satisfies that, and that is 4. It is both a square number and an even number. So if we're going to choose this at random, the probability equals 1 over 12. And that's the answer.